In one of my YouTube shorts, I showed you guys how to differentiate the absolute value of x, and we got x over absolute value of x, and that's actually the same as absolute value of x over x. And in that video, I got this awesome question. So, it's a differential equation x over y or y over x. Very cool. The quick answer for that is both of them could work. It depends on the initial condition. So let me just kind of put everything down right here for you guys nicely. First, we start with y equals absolute value of x. If you differentiate this right here, we can look at this as dy dx. We have x over absolute value of x, which is the same as y. Or we could also look at this as dy dx equals absolute value of x, which is y over x. Either way works. It depends on what you have for the initial condition. Let me show you the general solutions for both of them first. Starting with dy dx equals x over y. So I will multiply both sides by y and also the dx. We get y dy equals x dx. Integrate both sides. We get 1/2 y squared plus c1. Doesn't really matter though, just put a constant on the right hand side because we will have constants on both sides. Subtract the constant both sides, you still have a constant, just put it on the other side. And we have 1/2 x squared. I put plus c, here's my c1. Now to get the general solution, meaning isolate the y, I'm going to multiply everybody by 2 first. So that will be y squared equals x squared. 2 times c1 is still a constant. We can label that as c2. And then I will just take the square roots both sides like this. And don't forget the plus or minus. Cancel this out. Y equals plus or minus square root of x squared plus c2. And since this is the general solution, I don't need the subscript anymore. That's pretty much it. Okay, now let's look at this one right here. If we have dy dx equals y over x instead, this time we will have to divide both sides by y and then multiply dx both sides. So we get 1 over y dy equals 1 over x dx. And the same thing. Here it's ln absolute value of y and then ln absolute value of x. And here is my first constant. Exponentiate both sides, so cancel, cancel, and then we get absolute value of y equals e to this. It's the same as e to this power, e to the ln absolute value of x times e to the c1 power. This and that cancel nicely. This right here is just a constant, so we'll label that as c2. So absolute value of y equals c2, and then absolute value of x. Now to get rid of the absolute value for the y, you really just get rid of it like this, but put a plus or minus on the right hand side. So you can see y is going to be plus or minus. I have a constant c. I don't need a subscript anymore because this is a general solution like that. So these are the two general solutions for these two differential equations. And you can see for the second one, we have the absolute value of x right here already. But right here for this one, you can also end up with absolute value of x. Remember, square root of x squared gives you absolute value of x. Right now, you have to be careful with the plus or minus. To do so, we'll just have to make sure we provide a good initial condition. So let me just say, with the initial condition that y of, I know y of 0 is equal to 0 because absolute value of 0 gives us 0. However, if you put 0 for x and y for 0, right here and here, c is 0, but you don't know which one is what you have to take, the positive or the negative. So a better initial condition right here that you want to assign is something else besides that. Let's say 1 and 1. So now have a look. If we have that initial condition, when x is 1, y is 1, we get this, plus or minus square root of 1 squared plus c. So square root of c well, in order for this to be 1, c has to be 0. And then we also have to make sure we just get a positive, right? So just get rid of that. So as you can see right here, we end up y equals just square root of x squared, which is absolute value of x. Okay, right here, when we put 1 and 1 into x and y, so here is 1 plus or minus c and the absolute value of 1. So this 1 and c has to be positive 1, so let me just make c equals positive 1. So get rid of that, right? Get rid of that again. So this right here, we also get y equals absolute value of x. Yeah, very nice question. I have never thought about it. Thank you.